MCP, Model Context Protocol, is a buzzword, an AI-related buzzword you might have heard or read about over the last couple of weeks. And I actually also explored it and took a look at what it actually is and how you could build your own MCP server last week in my live stream with limited success, though the biggest problem simply was time, because the concept in general is not that complex and, despite all the hype, quite useful in my opinion. Now, I've also written an article, you find it below, link below, and I built an example MCP server and MCP client. I built an AI application that uses an MCP server and takes advantage of it, and you find that linked below this video and episode 2. Now, what is this MCP thing about though, and which problem does it solve? Well, to understand MCP, we have to start a bit earlier. We have to start with the basics, because my feeling is that not everybody understands those basics. We have to start with how LLMs and AI applications that use LLMs actually work, which might be trivial for some of you, but I feel like it's not clear to everyone, because it's super important to understand, to really understand, that all those LLMs just produce tokens. They just output tokens. They're token generators. And tokens, by the way, are words or parts of words. So they're text generators, you could say. Now, might be obvious, but to some people it isn't, as it seems, or they forgot about it. Some people think that nowadays those LLMs are those almighty tools that can use all kinds of tools, do all kinds of stuff, and that's not the case. They're generating text. That was the case in the past, that is the case today, that will be the case in the future. And it's the same for those more modern reasoning models. They're still just producing text in the end. Now, of course, you might say, but Max, ChatGPT and plenty of other AI chatbots nowadays can do much more than just produce text. They can perform web search. They may be able to run Python code. They may be able to do deep research. And you would be right. But do you know how they do it? That's the part we have to understand to then also understand which problem gets solved by MCPs. Those token generating tools, those token generating models, can use tools like web search because they're running inside of an application shell, you could say. So ChatGPT is such an application that uses an LLM as part of it, but it's not just that, but instead inside of that application, inside of ChatGPT, there is a lot of code probably written by engineers, software developers at OpenAI, and not by LLMs, by the way. There is some code that in the end, for example, injects a system prompt into the LLM, into the ChatGPT AI model that's running behind the scenes, into the O1 model or whatever it is that you're using. And in that system prompt, there are probably some guardrails being set up. There are probably some general instructions for the LLM on how it should behave when communicating with the user. There's probably stuff like this. And then there are also instructions injected about available tools and when those tools should be used. So something like, hey, you got the following tools available, and then maybe a list, web search, search query. So definitions of tools that should be available to the LLM. That's in the system prompt that's injected into the LLM. Now, if a user then asks something like, who is the current president of the United States of America? The LLM will generate tokens. Because of this injected system prompt, which includes a description of available tools, it's now more likely that it will actually produce tokens that describe this web search tool. So it will evaluate all kinds of tokens it could generate, but the most likely result will probably be that it outputs something like web search, and then some query, some web search query it would want to use if it had access to Google, for example. So it's all just likelihood, because based on all the data the LLM has been trained on and because of that system prompt injected for this specific user query, who's the current president of the United States, the most likely tokens that may be generated are the tokens that describe this tool use, because that might simply be more likely than some random hallucination, which would be the alternative without tools being available. However, I'm saying likely because it's not guaranteed that the tokens generated by the LLM will describe that tool use, despite the system prompt setup, despite all that. It still is just a probabilistic token generator in the end, and it could generate other tokens. It could generate some hallucination, for example. So it's not guaranteed that it will generate those tool use tokens, but it's quite likely. And the application in which the LLM is used, so the ChatGPT application, they will probably have some extra checks in there where they might filter out results produced by the LLM that might not seem optimal for the queries sent by the user, simply to provide a better user experience and also to control the output. But I don't know that. I don't work at OpenAI. That's just how it could work. Now, what if the LLM does produce those tokens that describe this tool use? What if it does produce web search : and then some search query it would like to execute in Google? Well, because it's using this clearly defined format, which, keep in mind, has been defined by the OpenAI developers in the system prompt that has been injected into ChatGPT, into this LLM before any user-generated content that's sent to it. Because of that clearly defined structure, this token sequence is probably returned by the LLM, and the ChatGPT application takes a look at the output by the LLM, and if it sees those clearly defined tokens, web search : search query, it will not output those to the screen of the user using ChatGPT. It will not use them as the final result. Instead, it will output something like searching the web ... and behind the scenes, some code written by OpenAI, not by the LLM. That's important. Not dynamically generated by the LLM, but instead some code written by OpenAI will be executed on OpenAI's servers, and there in that code, they will open up the Google website or use the Google API, whatever. This is just an example. Send that search query that was generated by the LLM to Google, get the results, and then once the results are there, send them back into the chat history that's used by the LLM. So as if this were some user-generated content, for example, but this is all happening behind the scenes, invisible to the user. The chat history is enriched by those search results, so that in that history, we have the system prompt, which is invisible to the user. Then we have the user question, which was written by the user. Then we have that assistant answer with the tool use it wants to use, which is also invisible to the user. Then we have the results of that tool, of that code being executed, which is also invisible to the user. And then based on all that chat history, which includes the search results, a new token sequence is generated by the LLM, and that is then likely the final result, which is then shown to the user. So the user does not see the entire chat history, but instead only the parts that are relevant to the user. That is how you could implement tool use. I don't know if that's exactly how it's done for ChatGPT, for example. I definitely don't know how exactly they're describing the tools to the LLM, but that is what has to happen in some way or the other behind the scenes, because those LLMs definitely are magic agents that have access to the internet. They just generate tokens, and they can only generate a request for using a tool, but then also only for tools that have been exposed to them, because the code for those tools had to be written by developers in advance and is controlled by the OpenAI developers, for example. So that is how tool use can work in AI-powered applications. And you could build such an application on your own. You could use the OpenAI API or any other model, of course, and you could create a system prompt that describes tools that should be available, and you could then try to write some code that parses the output of the LLM, checks whether your tools have been mentioned there, if the LLM wants to use them, then use the tool, feed the results of the tool usage back into the chat history, and produce the final result. You could build something like that if you wanted to. Now, in reality, if you wanted to provide tools to your AI application that you built with help of OpenAI's API or the API of other popular LLM model providers, you would probably not write your own system instructions where you list out your tools like that, but instead those APIs typically give you an easier way of exposing tools to the LLM. Now, for example, when using the OpenAI API, you could use its functions feature to inject the tools you want to make available to the LLM into the system prompt, so to say. That's how I do it in my example client implementation, which you find linked below the video. Nonetheless, behind the scenes, this will set some system instruction or inject some extra prompt into the LLM prompt that describes the tool to the LLM. It just does it in a way that is optimized for this specific LLM, you could say. You don't have to write the system instruction yourself, but it still will work the way I described it, just with a bit more convenience for you. Now, I have not mentioned MCP here though. I just described how tool use works, but that is important because MCPs, the Model Context Protocol, and things built based on that protocol are all about tool use in the end. So, which problems do they solve? Well, as I just described, you, as the developer of an AI application, you describe to the LLM, you inject into the system prompt, for example, a list of tools you want to expose. And you tell the LLM, hey, if you want to use that tool, use this special token, and maybe output some input values that are needed for the tool use. If you want to use another tool, output another clearly defined token. The problem with this approach is, of course, that every AI application has its own way of describing tools, has its own tools. And if you're, for example, the developer of an amazing hotel ratings application, a website that collects and gathers ratings for hotels from different sources, for example. If you're building such a website, you might want to expose that knowledge in a structured way to all those AI applications that are interested in it. Now, you have to rely on the developers of those AI applications to consider your website important enough to include it in the code of those AI applications, to make it available as a tool to the LLM, for example. With the MCP approach, the idea is to standardize the way how tools are described to LLMs and how tools are used, therefore, in the end. So you could build an MCP server, as it's called, for your hotel rating application, and you could describe that you want to expose a tool that gets all ratings for a given hotel or all ratings for a special region, for example. So you could have two tools, one tool for all ratings for a hotel, one tool for all ratings for a certain region in a certain country, whatever. Just an example. Because you're using this MCP protocol, you are describing those tools in a standardized way. How are you doing that? Well, there are official SDKs which you can use to build your MCP server. I built an example MCP server, as I said, and you find the code below for some dummy application that allows the LLM to store knowledge. And because you used that SDK, the tool will be described in a clearly defined standardized way to the LLM. You don't even see how it's described to the LLM. That's happening behind the scenes. The code for that is in the SDK code. But you have this clearly defined way of describing a tool. And because this way is clearly defined, you can build an MCP client, which would be an AI application that uses an LLM that wants to use MCP servers like that hotel rating server. You can build such a client use the MCP client SDK, which is able to communicate with such MCP servers. And in the end, that SDK will extract the tool description by the server so that you as a developer of that AI application, you don't have to come up with that list of tools that you want to expose. You don't have to write the code for checking whether the LLM wants to use a tool or not. You don't have to do any of that. You just use those SDKs and they will do the magic behind the scenes. So they give you a standardized way of exposing tools to LLMs. As the developer of such an MCP server, you are still the one who writes the actual code that will be executed when a tool is used. That is still not done by the LLM. You write the code instead. So that does not change. It's just the description of the tools and controlling the usage of the tools that is standardized. And the advantage of this MCP approach, and why I think that it's useful, is that we now have a standardized way of exposing all kinds of tools, all kinds of APIs to LLMs. Instead of having to wire them up manually on a per API or per tool basis, we can just build such an MCP server which wraps the logic for talking to the hotel rating API or for talking to the GitHub API or whatever it is. We can write such a server once, and then any AI application that wants to use this tool can just include and install our MCP server, and that's it. It does not have to write the instructions for the LLM on how to use that tool itself. Instead, the server can be installed and that's it. So it's an easier way of defining and sharing tools and of using those tools in a standardized way. That's the advantage. Now, I have read opinions that in the end, just say that MCP, this entire term, is just like a buzzword, just some hype. And in the past, we just used to call it an API. And to some extent, this is of course true. You could expose tools to LLMs before MCP 2. You could, in the end, connect your AI-powered application to any API you want. You could use Google Maps data in your AI-powered application way before MCP2, as I described in detail before. It's just the ease of exposing and using tools that makes MCPs and this model context protocol interesting, in my opinion. Now, it's quite likely, I would say, that in the future, there will be a list of MCP servers. I mean, there is a pretty extensive list of MCP servers already, which you can install into your MCP-enabled applications, like, for example, Cursor or Windsurf. These are AI applications in the end that support the MCP, the model context protocol already, and you can install MCP servers into those applications, for example. And you likely will not build your own MCP servers unless you are the developer of a service or an application that you want to expose as a tool. So you likely won't build your own MCP servers, but as a user of those AI applications, you can easily install extra tools into them to add new capabilities, which you might need for your personal workflow. Or if you're building an AI chatbot, which you want to sell to other users or companies, you could pre-install certain MCP servers so that your AI chatbot has certain tools available right from the start. And then you could or could not allow your customers to install more MCPs, for example. So that's what the MCP thing unlocks in the end. And that's why, in my opinion, it's not just some hype that's there. And I understand it. We have a lot of hype, a lot of buzzwords in the AI world. And typically, if you then check the accounts of the people that are creating the hype, they of course have some AI company or course they want to sell you. Sure, there is a lot of unnecessary hype. And you can believe me, I find that super annoying. But the MCP thing, in my opinion, doesn't sound too stupid. It sounds quite useful to me. That's that. I hope I could make it clear what this MCP thing is about. If anything's not clear, or if you got any comments on that, definitely let me know, as always, in the comments. Much appreciated, and have a great day. Bye.